Perimeter and circumference both measure a complete outside boundary. Straight-sided figures use perimeter, found by adding all outside side lengths. For a rectangle, the shortcut is 2 length plus 2 width. A circle's curved boundary is its circumference. Use 2 pi radius or pi diameter. Both answers are lengths, so both use linear units. Trace one complete trip around the outside before selecting segments. Boundary calculation never uses square units. A rectangle has 2 pairs of equal opposite sides. Let the length be 12 meters and the width be 7 meters. Perimeter equals 2 length plus 2 width. Substitute 2 times 12 plus 2 times 7. 24 plus 14 equals 38. The perimeter is 38 meters. Meters, not square meters, describe the distance around. Adding 12, 7, 12, and 7 gives the same total. A shortcut is trustworthy when you can explain the repeated sides. Circle circumference depends on either radius or diameter. Suppose a circle has radius 5 centimeters. Use circumference equals 2 pi radius. Substitute 2 times pi times 5. The exact circumference is 10 pi centimeters. Using pi gives approximately 31.42 centimeters. The curved boundary is a little more than 3 diameters long. The diameter is 10, and pi times 10 gives the same result. Use radius with 2 pi r or diameter with pi ad, but do not double both. A semicircle's full perimeter includes both a curved half circle and a straight diameter. Use radius 4 inches, so the diameter is 8 inches. Half the circumference is pi times the radius, which is 4 pi inches. Add the straight diameter of 8 inches. The exact perimeter is 4 pi plus 8. The approximate perimeter is 20.57 inches. Stopping after 4 pi would omit the flat edge. Trace the arc and then the diameter to confirm the boundary closes. Composite boundaries include every exposed outside segment. An irregular boundary becomes manageable when you label every exposed segment. An L-shaped region has outer horizontal lengths 9 and 4 units. Its vertical exposed lengths are 3, 5, and 8 units. Use alignment to find the missing horizontal segment. 9 minus 4 equals 5. List the boundary once as 9, 3, 4, 5, 5, and 8. Their sum is 34 units. The interior notch changes the path but does not create area units. Following the path clockwise prevents a segment from being skipped or counted twice. Label, infer, list, and add. Real boundary problems may remove an opening such as a gate or doorway. A rectangular yard is 20 by 15 feet with a 4-foot gate opening. Using 2 times 20 plus 2 times 15 gives 70 feet of closed boundary. The gate is part of the geometric perimeter, but not part of the fencing purchased. Calculate the full perimeter as 70 feet. Subtract the 4-foot opening. The required fencing is 66 feet. The context changes the material total, not the rectangle formula itself. A reasonable fencing answer must be slightly less than the full perimeter. Separate the geometric boundary from the practical quantity requested. 4 habits keep composite boundary work organized. Trace the outside path with a finger or pencil. Label every exposed straight or curved segment. Infer missing lengths from aligned totals before adding. Finish with one-dimensional units such as feet, meters, or centimeters. The trace controls completeness, and the unit confirms that you measured length. Count each exposed boundary segment exactly once. A clear path is more reliable than memorizing a special composite formula. Use a 4-step boundary routine for straight, curved, and composite figures. Identify the complete outside path. Write a formula or ordered segment list. Substitute known and inferred lengths. Check closure and report a linear unit. Challenge: find the perimeter of a semicircle with diameter 12 meters. The curved half is 6 pi meters and the straight diameter is 12 meters. The perimeter is 6 pi plus 12, approximately 30.85 meters. Trace first, include every exposed piece, and let the linear unit verify the model.